example 111. Because cardiac deaths appear to increase after heavy snowfalls, an experiment was designed to determine the cardiac demands of manually shoveling snow. 10 subjects cleared tracts of snow, and their maximum heart rates were recorded. Their average maximum heart rate was 175 with a standard deviation of 15. Assuming maximum heart rates are normally distributed, find the 95% confidence interval estimate of the population mean for those people who shovel snow manually. All right, so before we start working this problem out, we just want to mention or acknowledge the interesting nature of the topic, right? They're basically saying that somebody looked at records and saw that there were spikes in cardiac deaths, maybe arriving at the hospitals or emergency services reported the spike. But either way, they see this in the records and they start to wonder what causes it. And they have to come up with this clever idea that there's a connection between the weather outside and the spikes in cardiac deaths. That's pretty interesting, and it points to kind of the cleverness of the human mind. But either way, they suspect that maybe shoveling snow is so physically demanding that it causes people to have heart attacks. All right, so what we want to do in this problem, according to the problem, is find a 95% confidence interval. So I know it's a confidence interval, and it's designed to estimate the population mean. So I know we're looking to estimate the mean. So let's go ahead and do the first step of that process, which is to list the data. So we should have an n, and we should have an x bar, and we'll have a standard deviation and a confidence level, and we always have an alpha value. All right, so the n here says 10 subjects cleared tracts of snow. That's your sample size. Then it says their average maximum heart rate was 175 with a standard deviation of 15, right? A confidence level of 95%, and an alpha, of course, then of 0.05, which stems from the confidence level being 95%. All right, our next step is to get the critical value for the problem. The critical value is our table value, and I want you to get in the habit of looking at the n before going to the table. If the n is less than 30, we're going to go ahead and use t alpha divided by 2, right? So actually, if it's 30 or less, we'll use t alpha divided by 2. So there's your notation then. And let's think about what that is for this problem. Alpha is 5%, so half of that would be 0.025. And then the degrees of freedom that's necessary when using the t-distribution is just n minus 1. So we're going to say 10 minus 1, in which case we get 9. All right, let's go to our table and look that number up. Okay, so we're looking up 0.025 with 9 degrees of freedom. So here's the 0.025, and 9 degrees of freedom gives us 2.262. Okay, so we found the value 2.262. Once we have that critical value, our next step is to fill in the margin of error formula. That'll be t alpha divided by 2. S over the square root of n. So it's actually very similar to the formula we used when we were dealing with the z, or large sample problem, right? All right, now from there, the t alpha divided by 2 is 2.262. S here is 15 according to our step 1. And the square root of n is the square root of 10. Close it up and let's work it out. Before we actually work this calculation out, I would like to basically run a little check for us mentally before we start the calculation. That way when we finish the problem, we'll have some way to know if we're approximately correct or not. I think it's a good habit, so I'm just going to show you how to do it. Sometimes it's easier than others, but a quick mental approximation, the square root of 10 must be close to the square root of 9, because 9 and 10 are pretty close to one another, right? So the square root of 9 is 3, and that would go into 15 5 times. And then we'd have 5 times 2, roughly, which would be about 10. So we're saying that this calculation should be in the ballpark of 10. It's a good idea to do that mental approximation first so that you can catch any errors that you might make when you're working it out in your calculator. All right, so let's do it. It's 2.262 times 15 divided by the square root of 10. We close it up and we get the answer 10.729, so on and so forth. So 10.729 ... I'm just going to store that in my calculator now for the next step. Actually, we don't even need to use our calculator, I think, because we're probably better off working with whole numbers in this example, since we're dealing with maximum heart rates, and usually people give those as whole numbers. So let's finish up the final step. It's going to be essentially x bar minus the error, comma, x bar plus the error. And that's what we're looking to do in the final step. All right, so our x bar, remember, is 175. And we're going to be subtracting off 10.7, but if we're going to use whole numbers, let's just call that 11, right? And then 175 plus 11. And when we're finished, we get the answer. 11 from 175 is 164, correct? And 11 added to 175 is 186. And so this is the interval that's supposed to contain the population mean. So let's just finish up our problem by saying, hey, we are 95% confident the true mean maximum heart rate, right? Maximum heart rate is between 164 and 186 beats per minute, right? Okay, so that's our results. And the last thing we want to do maybe is to just think about something we learned in health class and see if we can interpret this interval beyond this little sentence that we've created. When you were in health class, you might have learned this formula that said 220 minus a person's age gives the target maximum heart rate when doing cardiovascular exercise. So if you were a 20-year-old, you would want to get to like 200 beats per minute to get the maximum cardiac conditioning basically from your workout. But if you've ever tried that, it's very stressful on the body to get your heart rate that high. So what if you were 60 years old? If you were 60 years old, it'd be 220 minus 60, right? So a 60-year-old man shouldn't get his heart rate higher than what? 160 beats per minute. That would be kind of the target exercise zone for the maximum cardiac, efficiency, or maximum cardiac, what's the benefit, I would say, from the workout. But again, as I mentioned before, that's very stressful on the body. And for somebody that's not in good health, it could be dangerous, right? So think about it. If your average heart rate, according to this, is somewhere between 164 and 186 when you're shoveling snow, it kind of indicates that if you're a 60-year-old man, and this is your target maximum heart rate, that this work of shoveling snow by yourself might be too stressful for your body, right? It might be, too much work for your heart, especially if you're out of shape. So doctors might look at this and say, hey, we got to advise our older patients in the winter to get someone younger to shovel their walk, or maybe to hire a company to do it, because it could be dangerous, especially if they're unhealthy. All right, so that's it, and we'll go on to the next problem, 112, and do that in our next video.